Okay, so what is the relationship between exponential and logarithmic functions? So I took this off of actually one of Khan Academy's videos because I figured I would kind of put two into one. Um, let's talk about logarithmic form. So here's logarithmic form, and then there's exponential form, which I'm sure is pretty clear which one's which. Exponential form is when there's an exponent, and logarithmic form is when there's a log. So here I want to turn this into logarithmic form. So just a reminder, we have y equals b to the x. It is the same thing as saying log base b. B is always the base. Here it is the base, here it is the base. Log base b of y equals x. So here I have 10 squared, or let's write it, 100 equals 10 squared. It is the same thing as me saying log base, my base is 10, log base 10 of 100 is equal to 2. I emphasized it in the last video, but it's really important here that you understand that the whole point of logarithms is to solve for an exponent. We are solving for an exponent. So logarithms are exponents. So here, my answer is going to be, I know the mouse is there because I took it, log base 10 of 100 is equal to 2. You can also write this as just log of 100. We're going to learn later on that when you have just log by itself with no base, it is assumed to be 100. Kind of like when we have a square root. When there's no index, it's assumed to be a 2. With logarithms, if there's no base, it's assumed to be a 10. So you could rewrite this as log of 100 equals 2 also. And then this one, rewrite the equation in exponential form. So I have log base 5 of 1 over 125 is equal to -3. So I kind of write it as a circle. So this to this power equals this. So it's going to be 5 to the -3rd power equals 1 over 125. It should be a true statement. If you look at it and it's like you wrote it wrong. Let's say hypothetically you were like, oh, 1 to the 125 to the 5th power equals -3. Like that's obviously wrong. So it should be correct. It should give you two true statements. These are equal. These are the same thing. Okay, it's just writing it in two different ways. It's like me saying the square root of x is equal to x to the 1/2. Same thing, same exact statement written in two different ways. So here I have 5 to the -3rd is equal to 1 over 125. Now, let's talk about the actual relationship between these two functions. If I have, and I wrote it above, y equals b to the x power, that is the same thing as me saying y log base, I'm going to actually rewrite it as x equals, right? Because the whole point is we're finding the exponent. X is equal to log base b of y. So the relationship between these, and I'm going to show you why, is that they are inverses of one another. These two specifically are equivalent, right? These are the same thing. If I graph this and if I graph this, they would look exactly the same. Now, what is an inverse? And we spoke about this in class. Inverses swap x and y. So what I'm going to do here is I'm actually going to do that. I'm going to swap x and y. So I'm going to rewrite this here as x equals b to the y power. So now these two are inverses of one another. Inverses. Because x and y are swapped. But when we did inverses, if you remember, if we had something like y equals 2x, we swapped it and x equals 2y, we had to solve for y. And so we got y equals x over 2. So this is not solved for y. So I'm going to move it to exponential form. So it's going to be y equals now, because y is my exponent, y equals log base b of x. Now I have a y equals statement. And this, my friends, is the inverse of this. So that means all of the xy coordinates are swapped. They are inverses. Inverses. That looks terrible. Okay. So that means that the inverse of y equals 2 to the x, for example, is log y equals log base 2 of x. These are inverses, right? Because if I rewrote this, it would be x equals log base 2 of y, and then if I swap x and y, I get this. So it's really important that we understand that logarithms and exponential functions are inverses of one another.